If we're going to solve by the elimination method, one of the ideas that we need to keep in mind is we need our x's and y's to line up underneath each other, and right now we don't have that. So if I'm going to solve by elimination, that's one of the things I'm going to need to do. You do have a method of substitution, and you could easily do that with this problem, but I'm going to keep with just the method of elimination. So I'm going to keep the first equation as is, variables on the left, constant on the right, and do that with this as well. So I'm going to subtract 4x from both sides. I'm going to keep the sign with the number, and I'm going to keep the x's underneath each other. So I'm going to keep the negative 4x in front, a positive y equals, and then the 2. And then it's my choice as to what I want to eliminate. So if I want to eliminate the x's, I want to multiply the top equation by some number so that when I add it to negative 4x, it'll cancel out. So if I put a multiply by 2, 2 times 2 is 4, which is the opposite of negative 4, so those will cancel out nicely. But I have to multiply everything by 2 in that line. Right, another way of thinking of it is, what do both 2 and 4 divide into? They both divide into 4. One has to be a negative 4, which is already what we have. The other one must be a positive 4. So to make that a positive 4, I have to multiply by 2. A 4x minus 6y equals 2. And then I keep the bottom equation as is. When you add these up, one of the variables must drop. And then solve for the remaining variable. Okay, so I get y equals negative 4/5, which means that's the y component of my point. Now I need to find the x. I could do like I did in the previous example, and that is plug the negative 4/5 back in for y and then solve for x, but it gets a little messy with the fraction. Another thing that you can do is go back to your equations. So we have 2x minus 3y equals 1 and negative 4x plus y equals 2. Remember last time we multiplied to get rid of the x. Well, I can go back and do this same thing, only now get rid of the y's and solve for x. And once I have my x value, I can plug it in here. So I can just do this problem again and eliminate the other variable. Sometimes that's easier than trying to plug a fraction back in. So if I'm going to do that, I take a look at, I have a negative 3y here, I have a positive 1y here. I'm going to need to multiply the bottom row by the number 3, because a positive 3 and a negative 3 will cancel. This time the entire top row stays the same. It's the bottom row now that's getting multiplied by 3. Alright, so I have a negative 10x equals 7 divided by negative 10, and x equals negative 7/10. So that's my value to put in the point there. I already had my y value from the first part. My x value now is negative 7/10. If I wanted to, I could plug this point back into both equations just to make sure that it fits.